Here are some more examples of the polynomial long division. I just want to say that I kind of had to wipe this out because it might have looked like it was a not equal sign over here on example 1, but it was an equal sign. So I redid that, so make sure you're careful. 18 plus 30 plus 10 equals 58. Okay, so here's a couple more examples. So let's take a look at our second example here. And we have to be careful because when we're doing a long division, when we're working with decimals, if we have a number like 102, okay, that actually means 1 times 100 plus 0 tens plus 2 ones. Okay, that's the way we expand numbers using our decimal system or our powers of 10 base system. All right, so we have a placeholder here. So we need to have placeholders, and the zeros are placeholders, and we understand them to be like that. So when we have a problem like this, we are missing the x squared. See, we have, this is like 1 times 10 squared plus 0 times 10 to the first power plus 2 times 10 to the 0. So we have these descending powers in our numbers, and they're already always filled in with placeholders. So we need to have all the descending powers here when we do long division, otherwise our numbers won't line up. That's all I'm trying to say here. Okay, so when I write this, I've got x plus 4, we're going to do long division, divided into 2x cubed. And then I don't have a x squared, so I've got to put maybe plus 0 times x squared, or just leave a blank there, minus 29x plus 13. So you have to leave a placeholder. So we have descending powers, 3, 2, 1, 0. That would be the x to the 0, which is 1. And then we could do our long division. So again, the first thing we do is divide. What do I have to multiply x by in order to get exactly 2x cubed? Well, 2x squared. We multiply that, so 2x squared times x will give me 2x cubed. And then this is going to be 2 times 4. It's going to be positive. 2 times 4 is 8x squared. Then we subtract, so we change the signs, and then add. That becomes 0, and then I've got negative 8x squared. Then I can bring down the negative 29x. Bring that down, and then repeat the process. So it's relatively straightforward. Just remember to put the placeholders there if we're missing. Oh, descending power. 3, 2, 1, 0. Okay, and then what do we have to multiply this x by in order to get negative 8x squared? So I need a negative 8 and an x. And that should do it. So I'll multiply. Negative 8x squared should be an exact match if I did it right, and then negative times a positive is a negative. 8 times 4 is 32, so 32x. Then I'll change the signs, make this a plus, make that a plus. That's 0, and 32 minus 29 is 3, so I've got 3x. 13, bring down the 13, of course. And I multiply x by 3 to make a match. And that's going to be 3x. And then plus 12. Change my signs. And 13 minus 12 is 1, so I've got a remainder of 1. So I could write the remainder over the divisor, plus 1 over x plus 4. And remember, if we evaluated this polynomial, then f of, what do you think f of negative 4? It's always the opposite sign. What would that be? That would be 1. Okay? And that's the remainder theorem. Okay, let's try another example here. I think we can fit another one in. And here we have a numerical coefficient in the divisor, so it's a little bit different. So we're going to divide this out, but we have all of our descending powers, so we don't need any placeholders, so that makes it a little bit easier. So again, the first thing I do is I divide. So what do I have to multiply 3x by in order to make it exactly 6x cubed? We just multiply by 2x squared, and that should do it. And multiply it and check. We've got 2 times 3 is 6. X times x squared is x cubed. And then 2 times 2 is 4 plus 4x squared. Change the signs. That's 0. And then negative 4x plus x squared is negative 3x squared. And then bring down your 7x. And then again, repeat the process. Need to multiply this by a negative 3x. And that's going to give me a negative times a positive is a negative 9x squared. Oops. This one should be 3. That should be 1. Shouldn't have made a mistake. See, if it doesn't match, then you know you made an error. That's why I got my white out here. It's got to be exactly the same, so I made an error. I just wasn't thinking. So I knew it didn't match, so I knew that's a real easy way to check yourself. So I just need a negative x, and that's going to give me a negative 3x squared, see? So a negative times a positive is negative 3x squared. Got to be a perfect match. And then the second one works out. Okay, well, hopefully we're careful there. So that's a negative times a positive is a negative 2x. And then when we change those signs, that's 0, and 7x plus 2x is 9x. So now we have 9x. Bring down your 10. And now I need to multiply by 3, just 3. Maybe that's where I was thinking the 3 was going to be, I don't know. And 3 times 3 is 9x. It's a perfect match. And then 3 times 2 is 6. And then we change our signs and add 0 and 4. So the remainder is 4. 10 minus 6 is 4, so it's going to be plus 4 over 3x plus 2. Now, since we have got a number in front, the remainder theorem does not apply here because it just has to be a binomial with a coefficient of 1. So the remainder theorem does not apply here. Okay? So we can't evaluate the polynomial. We can, but it's a little tricky, so we won't go into that. Okay, hope that makes sense.